session, we're going to talk about writing an Azure function in Java. So as you can see here, I have this resources open here. You can see there's a video here of Scott Hanselman trying to explain writing a Azure functions in Java. This is really outdated. This is shot in 2017, but some of the links are relevant here. So we're going to click on this link, create your first function with Java and Maven. I'm going to click on this link here. So this opens up to this section here, this quick start demo here, which we're going to use today. So the first thing to note is we need to set up the local environment. In order to set up the local environment, we have to follow the steps here. Make sure you have an Azure account with subscription. This point is optional because I'm going to show you how we can do without a subscription for now. We have to install azure-functions-core-tools. We have to install Azure CLI, the command line interface. We have to install the Java development kit, which is a version 8 or 11. I recommend 11 because it has LTS, long-term support, and also Apache Maven. So for this demo, I'm using my Mac, and I'm going to install everything using the brew commands here. But if you're using a Windows or Linux, you have to follow this documentation here. So let us proceed a little further. I'm going to do a prerequisite check here, as you can see here, so that all my installation is correct and we can get going. So I'm opening this command line here. So I have my command line here open and ready. I'm going to do first version check. So I'm going to say function version, and it says it's 3.0, which is good. I'm going to say AZ version. This is the Azure CLI version, which is 2.8, which is very good. And I'm going to log into Azure. I'm going to say AZ login. This is going to open Safari and do a login and bring back my tenant ID and everything else. As you can see here, it's going to open Safari. It's going to ask me to log in using this. I have already this account. This is my personal account. You can use your account. It is already logged in, and it's got the cloud name, the tenant ID, and the username, and so on. So now we can get going to start with creating an Azure function. Actually, you don't need to install, you don't need to log into Azure just yet, just to create the Azure function template and run locally. So I'm going to follow the documentation again. It says create a local function project. I'm going to use this Maven command line here. I'm going to copy this and then I'm going to paste it here. To use this to create my Azure functions Java template. So once you enter the command line here, it asks for a group ID. Now group ID is actually a value that groups all these functions together. So which can be like com.company name I can say cloud online, something like this, cloud online. Now the artifact ID is the name of the function itself, which can be like hello functions. I mean, in real world you will give a better name. It's okay. And then you have the version, which can be 1.0.snapshot. It's fine. And the package name is, so here it is actually copying the value of the group ID into the package name, which is not correct. I would give a different package name here. That'll be com.company name cloud function, cloud function. So you have Cloud Online as a group ID, and under Cloud Online you have this Cloud function. So here, if you see this summary here, you have the group ID as company name.cloud online. You have artifact ID as hello functions, and the package name is actually com.company name.cloud function, which is different from the group ID. You also have the app service plan name, which is Java Functions App Service Plan, which can be changed. And all these values that you see here will land in a file called pom.xml, which I'm going to show you. So I'm going to say yes here, and it's going to create all that stuff. So let's see what happens here. So I'm going to open this code, Visual Studio Code, and it will have a folder here already called hello functions. So I'm opening this pom.xml. I've opened this pom.xml file. So as you can see here, the group ID actually lands here. The group ID lands in this configuration file as Cloud Online, and the artifact ID is hello functions, and the version and the name is Azure Java function, which has to be changed. So this group ID is actually the same for, if I have 5 functions in this project, the group ID is the same for all the 5 functions, and also the namespace is inside this function. So let's have a look at that. Now, before I jump into the source code, I want to show you certain things here. Now, if I scroll down it, there is this plugin section here, and under the plugin section, you have a parameter called region, which defines what region this app function belongs to, and you also have the app service plan name. You have the app name, you have the resource group, which we have to change when you are going to production. Now the important thing here is the pricing tier and also the app insights. We have to enable app insights. The default is false. That means app insights is enabled. And the pricing tier should be, its default is consumption, but we have to change it to whatever is required by the client or whatever is valid. Now, the runtime is actually Linux. Here it's Windows, we have to change this to Linux, but for now we can leave it to Windows to run it locally, it's just fine. And the functions extension is 3, that is also okay. And that's it. So the pom.xml actually controls most of the parameters for deployment. It is part of the maven build. The next one we're going to talk about is the local settings. Now the local settings JSON is always there in git ignore, so it's always there somewhere in git ignore, so it doesn't actually get accidentally checked in. It has all the default values. We can add all the values that are needed in the working of a function, but when it's deployed to the cloud, it uses the settings or also the Azure key vault. Okay. And host.json has this is what it has. This is the default value. It has this extension bundle. Now we're gonna focus on the function.java. Okay, now what has actually generated. I'm gonna close this. Now here, so I have the package name as cloud function, as you can see here, which is different from the group ID, which is cloud online. Just to make sure you understand this. So I'm going back here again. So I have this package name as cloud function, and I have all these imported namespaces, which are very relevant to the Azure functions. I have now the class called function. This is the class called function, which can change. Now I have this attribute called function name, which says HTTP example. Now before I jump into this, right, so an Azure function, this particular Azure function is a HTTP endpoint, which means when you compile and run this function, it will become a HTTP endpoint, just like a REST API. Now the HTTP endpoint can be called in 2 ways. One is using a GET and there is a POST. As you can see here, in the comment here, both GET and POST are written here. The first one is the POST, which is because it has HTTP body here. And the second one is a GET because the body is actually in the name value, in the name parameter. So this is actually a GET way of GET invocation, and this is actually a POST invocation. Now coming to this Azure function signature, we have this method called run, which has this attribute called HttpTrigger, and which has the following parameters. One is the method, which is both get and post. We don't need to do both. We can remove one of these. The authorization level is anonymous. There are 3 authorization levels. Anonymous is the one which has no permissions at all, it just runs. For testing, we can leave it as it is. And then this parse query is actually when you run the Azure function, and when here we are trying to query this name key value pair. So when you query for name in the get URL, you will get the value as HTTP space query. So %20 is actually a space. It is it's encoded in HTTP encode. It actually represents a space. So when you do a get query parameter for the value name, you will see HTTP query as the value in this case. So let us run this and see what happens. Actually, let's run this, see what happens. Okay. So in order to run the function locally, I have to run two commands. One is mvn clean package and any mvn azure functions. So let's do that, and let's see what happens when you try to run locally. So first thing I'm going to do is I'm going to run mvn clean package. So notice that I'm inside the hello functions folder here. I'm inside the function folder here, and then I'm running this mvn clean package, which is the maven command here. This is going to take a while. It's going to run the tests, and it's going to say everything's okay. And then once everything is okay, I'm going to run mvn azure-functions-core-tools. Now this will give me an endpoint. Once I get an endpoint, I would know that I have to execute that endpoint for this to run. For example, here I have an endpoint here. So what it shows here, I have a get and a post. Both of them are enabled on this endpoint, which means I can do both get and post on this endpoint. So let's do that. I'm going to copy this, and I'm going to copy this, and I'm going to go to Postman. Let me open Postman here, and I'm going to paste it here. Notice that I've set the request type as get here, and there is nothing here. It's just a clean new request. I'm going to pass a parameter called name equals to Austin, and then I'm going to say send. So here I get as hello Austin, and here also I can see some logs that are being generated here. It shows the function name function.http examples, and it shows that it is a HTTP trigger. It's a HTTP trigger, that's why it is giving you a response back. It's a request response protocol, and it says it has executed this. It has taken about 200 milliseconds, 200 ms, and the output is actually here hello Austin. So this is actually a get. Let's do a post. So I'm going to make it a post here. I'm going to remove this because post will have a body. I'm going to go to the body section here, and I'm going to click, I'm going to say raw. I'm going to say raw, and I'm going to say JSON because that is the default standard, and I'm going to put some body here. So this is a JSON body, but I want to know how it is getting passed. So let's go back to the code again and see how data is getting passed so that I can get the body. So here, if you look at this, it says just get body. So it looks like it can be any body actually, because it's saying name is coming from a body or else query. So let's do get body, which is like any body. So let's try that. So let me do here. Let me go back here. I'm saying this is Naveen from Austin. So this is just any body. So I must be able to print all of this. So let's see what happens. So it says hello, this is Naveen from Austin. It's printing the whole body. So I'm going to remove these braces because it's not required. I think it's any plain body. I can use text here, and it works. This is Naveen from Austin. Or I can just say hello Naveen. There we go. So here, so we have seen all the different kinds of combinations here. One is the get request, one is the post request, and we have tried to execute this function here with the default values because we have not changed anything. We can change the function name, we can change the class name, because the class name and the function name are together appearing on the logs here. If you see the logs here, it is appearing with the class name and the function name. We can change these two. We have used both HTTP get and post. We can actually remove one of these. We have used anonymous authorization level. We can use different authorization levels. For example, you have function as an authorization level, you have admin as an authorization level. So we have used anonymous for now. Generally, while testing locally, you can use anonymous, but once you go to production or once you have environment specific code, we have to use a different authorization level. And then if the name is null, it says it's a bad request. We have not seen this because we have not had a name null. We can try that also. If I go back to the postman again, I can remove this and see what happens. I'm going to remove this and see what happens. So it still says 200. Okay. I'm looking for a bad request. So I'm going to get, and now there is a null here. So I'm going to see now I should get a bad request. I'm still getting a good request. That's good. It's very good. So basically, what is happening is when there is no data here, it is going to the query, which is the first one, and this always returns an empty value. If you look at the documentation of this, right? If it's unable to find the name attribute, it returns an empty value, and so it always hits the else portion here. So name is not null; it's never null actually. That's why it is working, and that's why it's showing as okay. Now let's talk about the unit testing part of it. For every function to work, we have to write a unit test so that the unit test actually validates the function and make sure that all the conditions are covered. We call this cyclomatic complexity. If we have multiple ifs and else and multiple conditions, there is a higher level of cyclomatic complexity. So for the cyclomatic complexity to be satisfied, we have to write different tests, and one of these tests is written here. It's a default test here. The most important thing to know here is the invocation and the verification. These two are the most important parts, and everything else is just setting up the test. For example, here we are having a query parameter of name as a value, name as the attribute, and Azure as the value. And here we are trying to get the body, and then here trying to invoke the function here using the mock HTTP response mock. So we are using the mock using the Mockito package here, as you can see here. And so we have to write these tests for every if and else condition that we have in the function to satisfy the cyclomatic complexity. See you guys in the next session. Thank you very much.